Let's now try to understand some of the deep learning methods, and one of the most prominent ones were the RCNN family. Now let's try to understand this what this RCNN is, because RCNN has got different versions or different avatars. It has got an RCNN, a FASTER-RCNN, and FASTER-RCNN. We'll understand the FASTER-RCNN and FASTER-RCNN. We need to understand what RCNN is. Now RCNN has got different moving parts. Like the first process is in terms of you input an image, and then after you input an image, you extract regions of proposal. What do you mean by regions of proposals? Are just proposals saying that okay, there is a likelihood of finding an object within this region, and to extract these regions of proposals, a kind of algorithm called a selective search was used. Now selective search can be talked as a very smarter way of doing this image pyramids and the sliding window, which we have earlier seen. So selective search gives much more likely regions of interest where objects are likely to be found. And once these regions of proposals are extracted, then the features are extracted from these regions. So regions of proposals are, as I said earlier, are only potential places where there is a very likelihood of finding this object. So from these regions of proposals, you extract features using a pre-trained CNN architecture. It could be an ImageNet or any of those CNN architecture. You do transfer learning and then extract features. Now this is all what happens in this, and from an CNN perspective. So the final step is about classification. So for the earlier family, or for the RCNN family, what is being done is a classifier is still done through a traditional model like an SVM, which does the classification. So there are four different moving parts, and the final classification through something like an SVM. Now RCNN was quite robust for quite some time, because a lot of lower level features were getting extracted using the CNN features, and then it was working well. However, these had some limitations in the sense that these were very slow. I mean, the RCNN architecture was completely slow, very slow, and it didn't scale well for real-time object detection, say for a video or any of these things. And it didn't have an end-to-end using the same architecture like CNN. It didn't have an end-to-end. So first you had to do these extractions, and you have to do the extractions using selective search. Then you feed it into a CNN, and from the CNN you then have to train SVMs to train for to detect many of these objects. And once these features are extracted through the CNN, then it is getting into SVM. So there are different moving parts, and it didn't have an end-to-end approach, and therefore the same authors came up with much more better algorithms, which is the FAST-RCNN and the FASTER-RCNN. So we'll see the FAST-RCNN and FASTER-RCNN next. Now, exactly after a year or 1.5 years after the RCNN was published, the authors came up with another improvement to the RCNN family, and it's called the FAST-RCNN. Now, the FAST-RCNN has got some interesting additions to it. Now, this is how it looks like. For a FAST-RCNN, first input image is given, and the features are extracted through a CNN layer. Once the features are extracted through a CNN layer, there is a new method called the ROA pooling layer. So what it does is, it's just like a fixed size window which is applied to the feature maps of the CNN to extract the features from it. And after the ROI pooling layer is done, so there are two fully connected layers, after which both the output, the class labels and the bounding box locations were also predicted. So one advantage of this fast RCNN was you could train end to end. You know, you saw in the RCNN that there were different moving parts. You have to have a selective search algorithm, then you have to have a CNN to extract features, then you have to have a SVMs to do a classifications. But unlike that, here you could do an end-to-end training for this. However, even though you have to train with the end-to-end with the CNN, at an inference time you still had to depend on an algorithm like your selective search to give us proposals of regions over which this fast RCNN was applied to give the predicted class and the bounding boxes. So however, so because of this, at the inference time, this fast RCNN had a terrible performance because you still had to depend on a selective search algorithm to give the proposals at the inference time. And this was corrected in another version of this, which came after a month or two after the FASTER-RCNN was published, called the FASTER-RCNN. Now we'll see what is it FASTER-RCNN next. When we talked about FASTER-RCNN, we saw that at the inference time it still used the selective search algorithm. Now the FASTER-RCNN tried to bake in this selective search inside the CNN module itself. So this and it's very similar to FASTER-RCNN, but the selective search algorithm is inside the FASTER-RCNN. So the whole architecture is like this. You have an input image, and from the input image, using a pre-trained convolution layer like an ImageNet or VGG16 or whatever, features are extracted. Now these features are fed into a new architecture called the region proposal network. Now region proposal network is a replacement of the selective search algorithm. So what this region proposal network does is it looks at those feature maps which is extracted from the convolution layer, and then looks objectively at it to see whether there is a likelihood of an object here or not. So it's like a binary classifier, not exactly like a binary classifier. What it does is it looks at each of those regions and then gives a probability that there is a likelihood of an object there or not. So once the convolution layer is passed through, after the feature maps are extracted, it goes parallelly in two ways. One link goes through the region proposal networks, and the other goes into the ROI pooling layer. Now once the region proposal network is done, it again goes through the ROI pooling layer. So ROI pooling layer is where a fixed window is run, and then you extract these features from these proposals, and then you get into the classification layer. Before the classification layer, you have two fully connected layers. One fully connected layer is for the classifier, whether an object is there or not, and the next is for the bounding box. So the advantage of FASTER-RCNN is you have the complete end-to-end in a simple network or in a single network, and it gave much better results than the FASTER-RCNN. So this is the overall overall RCNN family which we will discuss, and now we will go forward into another algorithm called the YOLO in the next slide. So YOLO, like the FASTER-RCNN, is also a straight through processing. That is, it has just one convolutional neural network where all these processes goes through, and it's much more simpler than RCNN model. So what it does is it takes an input image and extract the features through an CNN along with the bounding boxes as a regression problem. So all these things are finally predicted in the YOLO. So you have a bounding box for an object along with its confidence score in YOLO. Let's look at the YOLO in a little more detail. So What it does is YOLO divides an image into multiple grids like this, square grids like this. And for each of this grid, there is a kind of a prediction. There's a concept called the anchor boxes, which is actually a consolidation of the class or the probability that an object could be found in that particular grid, along with the coordinates of the bounding boxes, and what is the class of that object which is found. So each grid contains these anchor boxes, and once these and all these grids and all these anchor boxes are then fed into the convolutional neural networks, and then finally the prediction comes as like this, with the object wherever it is detected, and its probability, how probable it is that it's the object which you're looking at. So that's what YOLO does. The advantage of YOLO is in terms of it's very fast, and it is very apt for real-time object detections, like in videos and video clips. So, and that's the advantage of YOLO. It's much more faster than RCNN and other models. We'll deal with YOLO in the 5th post of the series, and we'll get into a little more detail about conceptually what YOLO is in that post. Now let's see the next object detector, which is the SSDs, in the next slide.